Hello, I'm Chris Mackey, and Colin Guru is my cameraman back there, and this is our final systems engineering presentation. So for the project, we followed a systems engineering approach following the V diagram, and the first three talk about creating design requirements and ways to test them. The second three talk about construction and prototyping, and the last one talks about integration and validation. You can find our requirements on slide 2 for this presentation that the link to this video is included in. So let's move straight into the designs here. So you can see our first design here. This is Reginald. He is made out of balsa wood. He's nice and lightweight. He's a little beat up from time spent in a box. And this one turned out to be inoperable. He didn't, well, he flapped his wings when he turned the crank. He didn't flap them when we wound up the rubber band and let go. So he passed the design requirements test, but not the systems. And this is because the crank here was biting, we think, and it was causing a lot of friction around the rotation point there as it rubbed against wood, and also is kind of trying to pull it in a bit. So it's causing a lot of undue rotation, a lot of unnecessary friction. So we said, okay, how can we fix this for the next design? And we moved on to Reginald II here, who we made a much more durable design. He's made out of basswood. He's a lot heavier, but he's a lot stronger. You see that we used copper tubing here to try and hold it steady and reduce friction, and we also did the same around the wings. If you look real closely, you can see that. You can see that we shortened the rubber band distance just a little to try and reduce this pulling on it too hard, and we made the wings a lot bigger so that hopefully you'd catch a lot more air and flap a lot better. This one also was inoperable, we think, because once again the rubber band was kind of biting it and then turning it inside the copper tubing, giving us friction and a lot of problems. And also the struts here were kind of attacking at a bad angle to flap the wings. So that brings us to Reginald III, who is once again made out of balsa wood. And he's a lot lighter. You can see he's much more compact. We actually switched up the rubber band so we could shorten this distance a lot. And you can see that he passes the design requirements test by flapping when you crank it. And the struts are going at a much nicer angle, and our hook is designed so that the rubber band's pulling straight back on it as much as possible to reduce the problems we've had in the past. So far he's passed the design requirements phase, but not the systems requirements validation. So let's get on to flight testing and see how he does.
All right, so here we have Reginald III wound up, ready to go. As you can see here, the rubber band is pretty wound up, and we're gonna let him go and see how he flies. All right. Okay, so as you can see from this flight, Reginald has some issues staying in the air, and we got about 3 flaps there. Probably could have gotten more if he had stayed in the air a little bit longer. So yeah, that's our flight test. All right, so some of the issues that Reginald III here is facing that we have also faced with our other designs, the main one being that we have to tighten this rubber band up a lot to even get Reginald to fly. And the reason for that is mainly just lack of lubrication and the fact that there's a lot of friction in the wood and the crank system, as well as a lot of tension in this rubber band. And over time, with having the rubber band so wound up, it allows for this joint right here that we've had on issues with on everyone to sort of get bitten into, causing a lot of stresses over time. Overall, though, this flight went a lot better than some of our previous flights. If we were to improve this, one thing we could do would be just to make some of the bends in our crank a little bit more 90-degree angled, get some lubrication for our system to make it have a lot less of those internal stresses and a lot less of that friction that we've been having. And I think that could solve some of our issues. Thank you for watching.